NEC Section 680.23 addresses specific requirements for electrical wiring and equipment in or around permanently installed pools, spas, and hot tubs, and it may not directly apply to the general wiring within a trailer itself, unless the trailer contains such a permanently installed aquatic feature. However, the principle of ensuring adequate conductor ampacity for the intended load is a fundamental requirement throughout the entire electrical code. The situation described, with a 40 amp plug feeding a 125 amp panel without upgrading the feed wires, presents a clear potential hazard and a violation of basic electrical safety principles. The primary concern is the undersized conductors. The National Electrical Code, or NEC, mandates that conductors must be sized to carry the intended load safely. Supplying a 125 amp panel with wiring only rated for 40 amps creates a significant risk of overheating, insulation damage, and potentially fire. While the main breaker in the 125 amp panel should trip if the total load exceeds 125 amps, the 40 amp rated wiring feeding the panel is still vulnerable to overload if the load exceeds 40 amps, even if it remains below 125 amps. This is because the main breaker only protects the panel's capacity, not the upstream wiring. The appropriate section of the NEC that would address this situation would likely be found in Article 310, which deals with conductors for general wiring. Specifically, NEC Section 310.15 and subsequent tables, like 310.16, dictate the allowable ampacities of insulated conductors based on their size, insulation type, and ambient temperature. To determine the correct wire size for a given ampacity, consult these tables. For example, if the wiring is type THHN copper and the ambient temperature is within the standard range, Table 310.16 would show the minimum wire gauge required for a 40 amp circuit. It's crucial to ensure the selected wire size meets or exceeds the 40 amp requirement and is suitable for the termination points in the panel and the plug. The authority having jurisdiction, or OJ, is the entity responsible for enforcing the NEC and other local electrical codes. As stated, this is typically the local building inspector or fire marshal. Their role is to review electrical installations, conduct inspections, and ensure compliance with safety standards. In this scenario, the AHJ would have the final say on whether the existing wiring is acceptable and what corrective actions are necessary. The AHJ has the authority to require the wiring to be upgraded to match the panel's capacity or to restrict the panel's usage to a maximum load that the existing wiring can safely handle. When dealing with electrical systems, it's always best to consult with a qualified electrician. They can assess the situation, perform the necessary calculations, and ensure the installation meets all applicable codes and safety standards. They can also communicate directly with the AHJ to obtain clarification on specific requirements or interpretations of the code. Several factors must be considered when determining the appropriate wire size for an electrical circuit. Firstly, the ampacity of the load must be accurately calculated. This involves adding up the amperage requirements of all devices and appliances that will be connected to the circuit simultaneously. Secondly, voltage drop must be taken into account, especially for long wire runs. Voltage drop occurs when the voltage at the end of the circuit is lower than the voltage at the source due to the resistance of the wires. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Thirdly, the ambient temperature in which the wires are installed must be considered. High temperatures can reduce the ampacity of wires, so it may be necessary to use larger wires or derate the circuit breaker. In the specific case of the trailer with the 40 amp plug and 125 amp panel, several potential solutions could be considered. Firstly, the simplest solution would be to upgrade the wiring from the plug to the panel to a size that is capable of handling 125 amps. This would involve replacing the existing wires with larger gauge wires and ensuring that all connections are properly made. Secondly, the main breaker in the 125 amp panel could be replaced with a smaller breaker, such as a 40 amp breaker. This would limit the total load that can be drawn from the panel to 40 amps, which is the capacity of the existing wiring. However, this solution may not be practical if the trailer requires more than 40 amps of power. Thirdly, a separate subpanel could be installed that is fed directly from the 40 amp plug. This subpanel would be sized to match the load requirements of the trailer, and the existing 125 amp panel would no longer be used. This solution would require additional wiring and equipment, but it may be the most practical option if the trailer requires a significant amount of power. It's crucial to remember that any electrical work should be performed by a qualified electrician who is familiar with the NEC and local electrical codes. Attempting to perform electrical work without the proper knowledge and experience can be dangerous and could result in serious injury or property damage. In addition to the NEC, there may be other applicable codes and standards that must be followed. For example, the National Fire Protection Association, or NFPA, publishes several standards related to electrical safety, such as NFPA 70E, which covers electrical safety in the workplace. These standards provide guidance on how to protect workers from electrical hazards. Furthermore, local jurisdictions may have their own electrical codes that are more stringent than the NEC. It's important to check with the local building department or fire marshal to determine which codes and standards apply in a specific area. When inspecting an electrical installation, the AHA will typically look for several key things. Firstly, they will check to ensure that all wiring is properly sized and installed. This includes verifying that the correct wire gauge is used, that all connections are properly made, and that the wiring is protected from physical damage. Secondly, they will check to ensure that all electrical equipment is properly grounded. Grounding is an essential safety measure that helps to prevent electrical shock. Thirdly, they will check to ensure that all overcurrent protection devices, such as circuit breakers and fuses, are properly sized and installed. Overcurrent protection devices are designed to protect wiring and equipment from damage caused by excessive current. Fourthly, they will check to ensure that all electrical equipment is properly labeled. Labeling helps to identify the voltage, amperage, and other important information about the equipment. In conclusion, the situation described with the 40 amp plug feeding a 125 amp panel without upgrading the feed wires is a clear violation of basic electrical safety principles and the NEC. The undersized wiring creates a significant risk of overheating, insulation damage, and potentially fire. The OJ, typically the local building inspector or fire marshal, has the authority to require the wiring to be upgraded or to restrict the panel's usage to a safe level. It's always best to consult with a qualified electrician to assess the situation and ensure that the installation meets all applicable codes and safety standards. Furthermore, it is crucial to consider other factors such as voltage drop and ambient temperature to ensure that the wiring is properly sized for the intended load. By following these guidelines, it is possible to ensure the safe and reliable operation of electrical systems in trailers and other similar applications. Always prioritize safety and adhere to the NEC and local electrical codes to prevent potential hazards. Remember, electrical safety is paramount, and any electrical work should be performed by qualified professionals to ensure compliance and prevent accidents. Understanding the principles of electrical wiring and the requirements of the NEC is essential for anyone working with electrical systems. This knowledge helps to ensure the safety of people and property and to prevent costly mistakes. It is recommended to consult the NEC and other relevant resources for detailed information on electrical wiring and safety. By staying informed and following best practices, it is possible to create safe and reliable electrical installations.